Good morning. Welcome to Mission Control Houston. This is Flight Control Room 1 at NASA's Johnson Space Center. These days, it's the home of the International Space Station Flight Control Team. But since 1966, it has supported flight control teams overseeing all of America's human spaceflight programs dating back to Apollo. I'll show you some of that in just a few minutes. This week, the teams in this room have been working with the International Space Station's Expedition 56 crew to keep the station operating in good shape to support the scientific research that's underway, including an experiment into the physiological changes experienced by plants on orbit.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Leah Cheshire. This week, the space station's resident farmer, better known as NASA astronaut Ricky Arnold, continued work on the Plant Habitat 1 investigation. In microgravity, plants experience a variety of physical and physiological changes, much like humans. On Monday, Ricky harvested Arabidopsis plants as part of a study that will help us better understand how microgravity affects photosynthesis, formation of cell walls, gene function, and more.
Well, they're doing great, and we're going to go ahead and remove the stems from them, and then we're going to remove the plants, freeze them, send them to the ground for analysis. And what's interesting here is typically these don't grow tangled like this.
This study's results could provide greater knowledge of basic plant science and benefit not only the efforts to grow plants in space, but also agriculture for us on Earth. Did you know there are microbial species living inside of you? This week, the crew worked on a study looking at the big role these tiny organisms can play. The microbes in our gastrointestinal tract help with digestion and interact with other organs, even the brain. When this brain-gut interaction is disrupted, the immune and metabolic systems may be affected, which could impact health in space. To learn more, scientists study model organisms, like rodents, because they have a well-understood genetic makeup that is similar to human systems. By comparing changes of organisms in space to a control group on Earth, we can learn how to protect astronaut health during missions and also guide treatment development for health disorders on Earth. This week's question comes from Landau, who asks where and how astronauts sleep in space. On the space station, astronauts have private crew quarters, an area just big enough for one person. Since there is no up or down, astronauts can snooze in any orientation and often strap their sleeping bags to a wall so they don't float around or bump into anything. Many also strap down their arms and head, and some astronauts wear earplugs to cancel out any noise inside the space station. Keep sending in your questions using the hashtag #SpaceToGround. We'll see you next week.
Off the Earth, for the Earth. Space to Ground.
The astronauts on the International Space Station spend a good chunk of their time as lab assistants on experiments in a whole range of scientific disciplines. Well, they also devote time to sharing the experience of spaceflight with people on the ground, particularly when they talk with students and their teachers about science, technology, engineering, and math during this year of education on station. In this installment of the STEMonstrations video series, astronaut and former classroom teacher Joe Acaba gets into the difference between kinetic energy and potential energy and demonstrates how one can become the other.
Welcome to the International Space Station. I'm astronaut Joe Acaba. Today, we're going to talk about potential and kinetic energy. Let's get started. Kinetic energy is the energy an object has because of its motion. An object can store energy based on its position. This is called potential energy. On Earth, imagine dropping an object from a raised position. As an object's altitude above the Earth's surface increases, its gravitational potential energy also increases. The potential energy stored due to its position is now being converted to kinetic energy. We also observe this with elastic potential energy.
Okay, new term. Elastic potential energy occurs when objects are compressed and stretched, or generally deformed in any manner, creating potential energy. Think of this bungee or a spring. Okay, Joe, what's next?
We pull back on the band and create potential energy. When we release the potential energy, it is converted to kinetic energy. Here on the International Space Station, we are still under the influence of gravity, primarily due to our position with the Earth. So when I have this ball on this ramp, normally back on Earth, I release the ball and it rolls down the ramp due to a change in its potential energy that's being transferred to kinetic energy. But as you can see, it doesn't happen here. So it doesn't mean we don't have potential energy. It just means we're not converting it at this time to kinetic energy. And why is that? Gravity is pulling us down, but we're moving super fast. And so what it is we're bending around the Earth in this perpetual falling motion. Thanks for joining me on board the International Space Station. We're sending it back to Earth so you can try your own experiment. See you next time.
Because a relatively small number of human beings has ever been to space, scientists who are studying how the human body responds to being in that environment need some help, like the use of model organisms. That is, living organisms that have a genetic makeup that's well documented and understood and similar to human systems, but which can be studied in larger numbers. Organisms like fruit flies. The laboratories on the International Space Station are designed to facilitate science that can't be done on Earth. The fact that the vehicle orbits 250 miles above the Earth makes that a terrific location for experiments that want to make scientific observations of the Earth over an extended period of time. The RapidScat wind measurement system has been doing just that for almost 4 years now.
A new angle on global wind measurements, presented by Science at NASA. Summer can bring with it a whirlwind of activity. Hurricane season causes potential havoc on land with threats of forceful winds and torrential rainfall. A helpful set of eyes mounted on the International Space Station allows scientists to observe these massive storms from a special angle, 51.6 degrees to be exact. That is the inclination of the space station's orbit around Earth. NASA's ISS Rapid Scatterometer, or ISS RapidScat, was launched and fixed to the space station in September 2014, giving it a view of the planet below that differs from any other wind measuring instrument. Brian Stiles, ISS RapidScat Science Processing Lead at NASA's Jet Propulsion Laboratory, says, because of its inclination, RapidScat observes storms in higher latitudes much more frequently than polar orbiting scatterometers. The same location can be observed several times per day, and this lets us see how storms are developing in more detail. The data that RapidScat provides is being used by NOAA to support marine weather forecasts and warnings, providing better observations of storms as they intensify and weaken. Zorana Jelinek, RapidScat project scientist at NOAA, says, RapidScat observations greatly aid in our ability to study temporal changes of wind fields. When observations are available, we have the ability to study changes within 1 hour at high latitudes. Previously, we were only able to characterize changes every 6 hours. In the tropics, RapidScat has improved the wind coverage of the space-borne scatterometer constellation from once every other day to more than once a day on average. ISS RapidScat is a radar, bouncing microwaves off the ocean surface and measuring the echo. Rough waters, those disturbed more by wind, return a stronger signal than smooth waters. From that information, scientists can derive wind speed as well as its direction based on the orientation of the waves. RapidScat excels at measuring winds at the ocean's surface, adds Stiles. Measurements of surface winds are important for many reasons. For one thing, surface winds define how the ocean and the atmosphere interact where they meet, which influences weather in the short and long time scales. Moreover, surface winds are what boats experience at sea, and people and buildings actually experience when a storm makes landfall. RapidScat provides remotely sensed ocean surface wind speeds and directions. With such a huge void of radar and surface observations over the oceans, remotely sensed ocean surface winds play an instrumental role in marine decision-making, forecasting, and modeling. Stiles says this is useful information for both weather forecasting and climate studies. Since it was launched, ISS RapidScat has seen dozens of storms, big and small. Maps of surface winds have given Earth scientists a unique view of the inner workings of these storms. The orbit of the space station covers the majority of the oceans from southern Canada all the way to the southern tip of South America every 48 hours. This means few storms escape RapidScat's relentless microwave scanning. These advantages are enticing weather forecasters and climatologists to make increasing use of the high-resolution wind data that ISS RapidScat offers. The information from these data are being utilized by marine forecasters at NOAA to help forecast, warn, and analyze wind and wave conditions over the ocean environment, from hurricanes and windstorms to fair weather conditions. Improved knowledge of impending wind and wave conditions impacts everything from large cargo ship routing to recreational boating to families vacationing along the coasts. As summer unfolds, ISS RapidScat will have a lot to do. For more from the International Space Station, go to www.nasa.gov/station. Stay tuned for updates from science.nasa.gov.
The exterior of the International Space Station is home to many ongoing experiments. Another one of these is a third-generation investigation into the state of the ozone layer of Earth's atmosphere. Marilee Roell of NASA's Langley Research Center explains how the third iteration of the stratospheric aerosol and gas experiment measures the ozone, aerosols, and other components of the atmosphere for scientists who hope to see an improvement in the atmosphere's ability to protect the planet and everyone and everything on it from harmful ultraviolet radiation.
SAGE stands for Stratospheric Aerosol and Gas Experiment. It's the third generation, so we call it SAGE 3. What it does is it looks at ozone, water vapor, aerosols in the atmosphere using a solar occultation technique. So it locked onto the sun or the moon, and it tracks that as it rises through the atmosphere or sets through the atmosphere of the planet, so that we can get vertical profiles of those gases. More specifically, it's ozone that we're really tracking. We hope to see recovering ozone throughout the entire stratosphere. So, and ozone's very important. It protects us from the UV radiation. Without that protection, we would have lowered crop yields. Our plants really don't like UV radiation, and we would have problems too. We would have more skin cancers and cataracts. So we really need that ozone layer in the stratosphere to protect us. I've been working on this for 20 years now, and it's going to be amazing to watch it up there and get up there and watch the data coming down.
For long-duration space missions to the International Space Station, or one day to the Moon and Mars, it's important to be able to ensure clean air for crew members to breathe. Now, that's the reason for electronic nose. Anna Grinberg, a systems engineer for microgravity payloads at Airbus, explains how ENOS analyzes the atmosphere inside the space station to provide rapid advanced warning of potential contaminant buildup.
As we know, the space station is it's a closed environment. It's been up there for 16 years now. So there's bacteria, there are fungi, microbes. ENOS is a device we've built that can go around and detect in different areas microbial content. It's interesting from a scientific standpoint. We can look at the flora and the fauna of the space station and see how it's changing, how things are becoming more virulent or evolving. And on the other side, it's just interesting from a public health standpoint to understand what the environment is. But the cool thing with this as well is it's also done with support from companies on ground who use this technology in hospitals or other settings on ground. So this project has many iterations. It started with a basic model and it's constantly expanding to address different types of samples. Basically, it's a long tube it's got a sensor set, it's an electronic box, and there's a few different nozzles. So one is very easy to attach to a flat surface like the front of a rack. Looks like a huge suction cup. And then another attachment to reach behind the racks is a long nozzle, also with a little nozzle on the very end. I think now what's interesting going to talk to commercial users is that people are excited that they can now use it and access it, because for so long it was not something that was accessible to everybody, and I think that's really changing now, and that's really exciting, and I think that will be a huge impetus for even new developments that we never saw coming.
NASA's future exploration efforts include development of the spaceship that will carry astronauts beyond low Earth orbit one day. Major manufacturing of hardware is underway to support what's known as Exploration Mission 1. It'll be the first launch of the Orion spacecraft using the new Space Launch System rocket and the attendant ground systems. Now, this flight will not have humans on board, but it will pave the way for the missions that will. There is science about space, and there is science to support future space exploration. And then some of the science on the International Space Station is aimed a little closer to home. It's helping improve the lives of us Earthlings who never get to leave the planet. Take a look at just a few examples.
The International Space Station is the most fantastic vehicle ever built.
It's a one-of-a-kind laboratory orbiting about 250 miles above the Earth.
And we perform experiments on the International Space Station.
We can do science, we can do experiments, we can learn how to do things out of this world. And the result will help benefit the people on the ground.
The space station really provides an opportunity to explore, for example, say medical applications.
The aging and the osteoporosis and muscle wasting conditions are greatly accelerated in microgravity.
The weightless environment will give us insights into things like diabetes and maybe even cancer.
Understanding those phenomena allow us to look at how we can improve treatment of disease here on Earth.
If we wouldn't have conducted experiments on the ISS, we wouldn't have known that you could use cold atmospheric plasma in such broad application areas we're now exploring.
One of the most promising results has been gained by studying a protein associated with Duchenne muscular dystrophy.
We may be able to slow the disease by half, potentially doubling the lifespan of many of these DMD patients.
We provided eyes-serve imagery for many, many natural disasters, including floods and fires, for deforestations, for volcanic eruptions, and for earthquakes. So it was really a fantastic example showing how imagery from the International Space Station could be used in these times of dire need.
This was when we realized we had a chance to make a difference in the world using the same technology that was used by NASA, but applied in a remote area of a developing country.
I think it's made people much more aware of the issues of water quality. That's a very powerful thing.
Having the HYCO on the International Space Station has been the ideal test bed for our research.
We can monitor these water bodies from space, and if we can reduce exposures both to humans and even animals, then we've achieved our goal.
And now today, we're able to operate the largest fleet of Earth imaging satellites in human history.
And none of that would have been possible without the International Space Station.
The space station has done so many things for life on planet Earth. It shows us what human beings can do working together. It shows the science that we can discover.
Over 2,000 experiments have flown on board ISS. 170 countries around the world have participated in some fashion, either in the ISS itself or in one of the experiments. Our rate of research is actually increasing. We're doing more today on board the space station for research than we have ever done before, and that's only going to continue in the future.
And so what we're seeing today is a proliferation of new ideas and new concepts. It's almost like it's a renaissance of what's happening in space. Buckle up and strap down, because this is going to be a rocket for all of us in the global community to be part of.
International Space Station flight engineer Serena Aunen-Chancellor is on her first spaceflight as an astronaut, but it is not her first mission for NASA. The Indiana native, who graduated from high school in Colorado, went off to college with an eye toward working at NASA someday, and she spent almost 3 years as a NASA flight surgeon before becoming an astronaut. But did you also know that she has mismatched twin dogs, a background in martial arts, and a college baseball Jones? Here are 5 things you didn't know about Expedition 56's Flight Engineer 6.
Five things that you probably didn't know about me. Probably number 1, our family has 2 dogs who really think they are brothers. And one is a 130-pound French Mastiff named Boss Hogg, and the other is a 12-pound miniature dachshund named Oscar. And they run around together, and they think they are absolute brothers and absolutely the same, but they are absolutely the heart and soul of our family. Number 2, our family absolutely loves to watch Aggie baseball. It's one of the favorite things that we do together as much as we can, certainly during baseball season in the spring. And in fact, it was the last thing we did before coming out to Russia to prepare for launch. We watched the Aggies play baseball at the University of Tennessee. Number 3, I actually do still practice medicine. I'm an active physician, and one of my favorite places to see patients is at a free clinic in Galveston, Texas, where we practice medicine for the underserved and those who can't afford medical care and do not have insurance, and that's at St. Vincent's House in Galveston, Texas. Completely student-run free clinic, but it's one of the joys. I love going there, and I love seeing my patients, and it allows me to teach medical students and residents really how to practice medicine in an underserved environment, and something I enjoy doing every week when I'm able. Number 4, my husband and I had a very non-traditional wedding on a 1,000-acre ranch, and part of our wedding reception, we actually had a rodeo event, and there was a big calf roping event that occurred, and most of our guests say they had never ever been to a wedding or a reception like that, but thought it was the best thing they'd ever been to. Final one, number 5, something many people do not know about me is that when I was getting my bachelor's degree at the George Washington University, I also needed to work to earn some money. And so I actually taught martial arts. I taught Kung Fu to school-age kids from age 5 to about 15. I would do that 3 times a week, and that's how I earned money in college, teaching martial arts.
Since the days of the Gemini program, America's human spaceflights have been controlled by teams here in Houston. But the tools have evolved with the times. Here's a tour of Mission Control Houston from its first generation through to the facility ready for the flights of Orion, the spacecraft that will take humans farther into space than we've ever gone before. If you'd like to get another look at any of the stories we feature today, check us out online on YouTube and on Facebook. There are the addresses right in the handy blue box. While you're at those spots, take a look at the other cool stuff you can find about NASA and America's human spaceflight program. You should also check out Houston, We Have a Podcast, featuring folks here at NASA talking about their jobs in all aspects of space exploration. New episodes are posting every Fridays. Today, July 27th, my colleague Gary Jordan talks with a couple of experts here at JSC about what it'll really take to learn to live off the land when humans finally get to the moon and Mars and have to figure out how astronauts can provide for themselves. Go to www.nasa.gov/Johnson/HWP. That's Houston, We Have a Podcast. You can find all the episodes there. You can also find them all on iTunes, Google Play, and SoundCloud. This is Mission Control Houston.